They can be broadly divided into two categories. One is mathematical models. The second one is deep learning techniques. So far, whatever we have learned, all those SVM, decision tree, linear regression techniques, those were based on mathematical models. Deep learning techniques are inspired by the way human brain works. Now, when you look at human brain, it consists of trillions of neurons. And what happens is these neurons are connected by synapses, and the chemical signal passes through this synapses, and these neurons are fired, and that's how humans make decisions or learn different things. When we learn different things, these connections are made more stronger or weaker, and based on that, it decides the quality of your decision. So the artificial neural networks are inspired by this basic functioning.
Here is the very simple neural network model. As you can see in the image, it has input layer, hidden layer, and the output layer. There could be more than one hidden layers. The circles that you are seeing here are the neurons, and the arrows are synapses that connect these neurons. Let's say you want to use this neural network for image identification. You want to know whether the given image is of a car or a cow. The way it will work is, first you will train the neural network, and then you will use the trained network for making prediction. So in the training step, you will feed an image of a cow, and using some algorithms, it will kind of create these pathways from input to output. And these blue colors means these neurons are fired, and the weights of these synapses or the edges are adjusted. Now we will look into those algorithms little later, because deep learning field is so vast that if we start going into mathematics and the theory behind it, we will not be able to start our coding. Okay, so I want to keep it very brief, and if you want to go more into the theory, you can bear with me, and we will do it later on, or you can read some other material. But just imagine that you have two endpoints, and you are kind of creating these pathways by giving the image of a cow. Okay, so that is your training step. Same thing happens when you give another image of a cow. Some other weights are adjusted, and some other pathways are created from input to output. Same thing happens for a car, where you can see a different set of synapses and neurons are fired, and different pathway is created. Once your neural network is trained, you can now feed any input image, and it will tell you whether it's a cow or a car. Basically, it will take one of the routes from here to here, and then it will make a prediction for you. Going little more into the detail, here is the neuron, and these are the edges or synapses. These edges have weights, and there are inputs to these neurons, and these inputs are just the real numbers. So we first calculate the weighted sum of these inputs along with some bias, and then that x is fed into an activation function, and that will decide the actual output of a neuron. This is how a neuron gets fired. Now there are three basic activation functions: step, sigmoid, and ReLU. There are more activation functions, but these are the ones that we are going to go through in this tutorial. And the step function is pretty simple. If the value is less than 0, then you say, okay, it's 0. And if the value is greater than 0, then it is 1. So this is how the step function looks like. Sigmoid function is similar to step, but it doesn't have an abrupt jump at a value of 0. It has a little smoother transition, and this is the equation for the sigmoid function. We have looked into sigmoid function in our earlier tutorial as well. The ReLU is a very popular activation function. It is also pronounced as ReLU, or some people call it ReLU. And here the formula is pretty simple. If the value is less than 0, then the activation is 0. If it is greater than 0, then the activation is whatever value you got as an input. We are going to use Keras in our tutorial for doing coding. Now the reason we are using Keras is because it's very easy to use, and this is something that a beginner should start with. Underneath, it uses one of these three libraries as its backend or a computation engine. TensorFlow is from Google, Microsoft came up with CNTK library, and University of Montreal came up with Theano. So Keras will use one of these three as a backend, and it provides a nice higher level wrapper or an API that you can use for coding your neural networks. Now going on to installation part, what you need to do is, so first of all we are going to use TensorFlow as a backend. So first you do pip install TensorFlow, it will install the TensorFlow library, and then you can do pip install Keras. So these two steps are enough for setting up your computer. So once you have set up these two libraries, we can start coding